Hi everyone. Okay, so in this video, I'm going to talk about the properties of convolution. So the first one is it's commutative. Commutative. Is that how you spell it? That's a V. Yeah. Which means the order does not matter. So if I have x of n convoluted with h of n, then I could flip those. So I could do h of n convoluted with x of n. And for the continuous case, same thing. X of t convoluted with h of t will equal h of t convoluted with x of t. Right. Let me scroll up. It's just on the screen. Okay. Property 2. It's associative. Associative. Which means I could take the convolution of either the first two and then convolute with the third one, or the last two and convolute with the first one after. So the order does not matter. Which means if I have 3 functions like that, and I want to convolute all 3 of them, the order does not matter. So I could do these first 2 and then convolute the last one, and that would still equal if I were to convolute the last 2 functions and then convolute the first function. Or I am running out of space. It equals, it could also be that I convolute the first one and the last one and then convolute the remaining one. F of n convolute with g of n. And it's similar for the continuous case where it's x of t convoluted with h of t. Let me put h1. h1 of t convoluted h2 of t will still equal x of t convoluted with h1 of t convoluted with h2 of t. Or I could do x, that's an equal sign, x of t convoluted with h2 of t, and then convoluted that with h1 of t. So it doesn't matter which 2 you do first, they'll still all be the same. Okay. And the last property, let me scroll up, is it is distributive. Is how you spell it? Distributive. Yes. Okay. Which means if I have this x of n convoluted with h1 of n times x, plus. Never mind, this is a plus. Plus x2 of n. Nope, this is supposed to be an x. X convoluted with h2 of n. Let me write that a little more clear. Of n. This could be rewritten as x of n times h1 of n plus h2 of n. For the continuous case, x of t convoluted with h1 of t plus x of t convoluted with h2 of t. And similarly, you can just pull out the xt. X of t is So this becomes h1 of t convolute. Oh, plus. I forgot the convolution sign. Oh, this is supposed to be convoluted. Convoluted. Right there. Plus h2 of t. Let me again write that a little better. So the distributive property states that if it's being added and it's being convoluted by the same signal, you can pull that out. And so you could add h1 plus h2 and then convolute it with x. Yeah. So your three properties are commutative, associative, and distributive. Right. Well, that's it for this video. Thanks for watching. See y'all next time.